The next chapter is type checking. So type checking is not just a standalone process that is performed by compilers, but one of the semantic analysis tasks. So during semantic analysis, one subtask performed by compilers is type checking. So this type checking is very important for strongly typed programming languages like C#, C++, or Java. Those are the strongly typed programming languages. Why? Because without declaring a given variable, we cannot directly use one particular variable, or without specifying the data type or the data type of the variable, we cannot directly assign a given value. So for weakly typed programming languages like the scripting language PHP we can consider, or the interpreted language Python we can also consider. Those languages do not need the prior declaration or declaration of a variable in advance. So without declaring or specifying the data type of the variable for which we are using that particular variable in a program, we can simply assign the value that we want to assign in the variable, and then internally the interpreter then determines the data type of the variable from the value that we assign in the variable. During the semantic analysis, the compiler must check if the source program follows the semantic conventions of the source language. So that checking can be performed during the compilation process, which is termed as static checking, and the checking can also be performed during the runtime or the execution of the program, which is termed as dynamic checking. So from the static checkings, type checking is one task, another uniqueness checking, flow control checking, and name related checking. So those are the type of checkings that are performed during the compilation process as a static checking tasks. The type checker of the strongly typed language verifies the type construct that matches the expected by its context. So for example, in a given programming language, for performing the modulo operation or for calculating the remainder of two variables using the modulo operator, the function or the operator modulo requires or expects variables of an integer type. In some programming languages, the modulo operator expects variables of integer type. So if one of the variables is not of an integer type, the remainder that will be calculated by the operator will not be correct. So the type incompatibility issue will be created. So so before applying this operator on the two operands, the type compatibility checking should be done on and the two operands. Almost all programming languages types are either basic or constructed. So every programming language has its own set of legal data types. either as a basic or as constructed or as a primitive data types. Primitive data types and the derived data types. The primitive data types like the boolean, the character, the integer, the real, and others. And the others we can consider. The constructed types can be arrays, the record is the set list, and others we can also consider. So the derived ones are derived from the primitive or from the basic ones. So for example, arrays are derived from either a set of characters, which are strings, or from the set of just formed as a set of integers. So from the integer basic type we can have a set of values of an integer type, or we can have a set of floating point, which is the real. We can just define records like structures from the set of primitive data types. Okay, so for performing the type checking, the semantic analyzer needs a set of rules, and those set of rules are defined in the form of type expressions. So what a type expression is, just we can consider the type expression as a rule that contains how the types that are accepted or that are legal as per the context of the language is specified. So the expression that shows how the type of the legal type of the language is expressed is what you call the type expression. So the type of language construct will be denoted by type expression. The type expression is either a basic type or formed by applying the operator called type constructor to type expression. So we can consider each type expression, each basic type or the primitive type as type expression, the primitive type. So like the int, the car, the boolean, and others. So individually the data types, each individual basic data type is considered as type expression. And the constructed types are the ones that are formed by applying the type constructor on the basic type expression. So the type constructor applied to the type expression is a type expression. So it's another type expression. For example, we can consider arrays as a constructed type, and those constructors of the type of arrays can be expressed as array I comma t, where I is indicating the index set and t indicating the type expression, the basic type. And for the pointers type expression, another constructed type expression as pointer, then t, where t is a type expression. So the type expression and the declaration of the pointer type, we mostly specify the data type and the asterisks. Functions constructed type expression, mostly we just simply express functions as a mapping between the parameters, the type expression of the parameters, and the return type of the function. So we can simply express function constructed type as a mapping between the data type of the parameters and the return type of the function. And we can have other constructed types. So for letting the semantic analyzer perform the type checking, we need to define the set of rules, set of semantic rules that can enable the semantic analyzer perform the semantic analysis. And those set of semantic rules are defined using the translation schemes. For example, for this production rule, E drives E1 in bracket E2. So for this production rule, we can add the semantic rule, which is the semantic action, and the form of translation scheme. So by adding the translation, the semantic action at the end of the production rule. So this production rule or this translation scheme is representing function calling statement type checking. So we can consider E1 as the return type, the function name, and E2 representing the arguments. So we can define the rule, the semantic rule, as E dot type equal the type of E assigned by T if E2 dot type is equal S and E1 dot type is equal to ST, the mapping between the parameters, and the arguments. So if that means if the parameters, data type, and the arguments data type is properly matched, and the parameter and the return type is properly matched, then the data type will be T, the E data type will be T, otherwise it will be considered as an error. And another is the type expression for the a literal data type. E dot type is equal to car. So the literal constant for any literal constant can be character literal, or it can be string literal. So for both of those values, the data type is car. Then for number expression, the data type is an integer. For an identifier, we need to look the type of the identifier from the symbol table of the compiler. So the identifier data type should be accessed or referred from the symbol table. That's why after accessing the data type of the identifier from the symbol table, then assign that data type to E. That is, the next one is the modulo operator. How the modulo operator can be legally applied here in a strongly typed programming language, and in which the modulo is expecting the parameters data type to be an integer. So the data type of the symbol on the left side of the production rule will be the data type will be the data type integer if e1 dot type is equal integer and e2 is equal to integer. Otherwise, if either of the operands is not an integer, the value of e type will be type error. And the next one is the data type of the array declaration. So the type statement will be assigned the type t as a an error, and this type t will be assigned if an e2, which is the data type of the length, the size of the data type of the size of the array, or the number of elements of the array, that is integer, because always the size or the number of elements should be of an integer. You cannot use the number of elements as a floating point or any other data type other than the integer. So first we need to check whether the specified size of the elements is of integer type, and e type is properly specified as an array or properly followed the array declaration syntax. So if the two conditions become true, then the type of e will be assigned t, otherwise type error. And this one is the rule for the pointer variable, the use of pointer variable. So this is just to indicate, this symbol is to indicate that the variable is a pointer variable. So the data type of the type expression can be evaluated, and the e dot type will be assigned the type t if the e2 type is equal to pointer. That is, if this one is not e2 but e1. This should be corrected, e1. So if e1 dot type is just expressed or specified as a pointer variable, if it followed the pointer variable declaration syntax. If that is true, then the type is t, otherwise type error. So we can define the type expression for those different type the type of statements. So each statement in the program should be checked for correctness of the use of data type. So those are the remaining types. The remaining types of statements that we should consider for letting the semantic analyzer check their type validity. So the assignment statement, the type can be checked. So the S data type will be void or type expression. So if id a type is equal to the e dot type, then it is void, otherwise the type expression error. So if a statement can also be checked for the type expression validity, so as we can just recall how to write the if expression statement. So if expression statement can be written as if, then the condition, the e part is representing the condition of the if statement, and the S1 is the set of representing the set of statements that will be executed if the condition E is correct. So this type expression can be simply specified as type, the translation scheme, as the statement type equal if the type equal to the S1 dot type if the type expression of the E part of the condition part is equal to the boolean. So because E part should be a boolean expression, or the E should be an expression that will be evaluated to either true or false. If not, then the type error will happen. Okay, the next point is equivalence of type expression. So in defining type expressions as the rule of type checking mechanism, we may have some type expressions as equivalent type expressions, and two type expressions are structurally equivalent if and only if they are the same basic type or are formed by applying the same constructor to structurally equivalent types. For example, integer is equivalent to integer type because integer is a basic type expression or the primitive type expression, and for example float is equivalent to float. So if two float type expressions are defined, then we can say the two type expressions are equivalent. Car is equivalent to car, but integer cannot be equivalent to car. Car cannot be equivalent to float because there are two different type expressions. But we can also have an equivalent type expressions that are formed from the other primitive types. So we can also have constructed type expressions which are equivalent. So for example, int a in square bracket 2, this is simply the declaration of an array the array variable. So here this array declaration of the variable a, the array of size 2, can be structurally equivalent with another array b with size 4. Since both arrays are of type int, we can say they are equivalent, structurally equivalent. They are structurally equivalent. Why? Because they are of the same data type int, and again they are of the same constructed type array. So but here, for example, we cannot just equate, or we cannot consider them as equivalent if, for example, a is of type float and b is of type int. So if although they are structurally just of the constructed type array, the one is constructed from the float and the other one is constructed from the int. So since there is a difference in type expression, the primitive data type usage, so we can say both are not equivalent. So both expressions or any two type expression can be considered as equivalent. Either they are from the same basic type, or they are formed by applying the same constructor. That is, they are formed by the same, like array, or of the same type array, of the same, like pointer, like the function, or if it is if they are of the same basic type, int, float, or double, or char. So the for the equivalence of type expressions, such criteria should be considered. The other concept is type conversion. Conversion may be performed internally by the compiler, or may be performed by the statements explicitly defined by the programmer. So if the type conversion is done by the statements defined by the programmer, explicitly defined by the programmer, then we call it explicit type conversion. If it is done internally by the compiler, we call it implicit type conversion. For example, if float is, if the programmer just defined a statement like float pi equals 3.14, and another statement that assigning the value of pi on a variable of int type, here the pi is first converted into integer, and then the result is assigned on the variable x, which is of type int. So in order to just make the value compatible with the type of the variable x, here the programmer is explicitly specified the conversion of the pi. So this is an example of explicit type conversion, and the implicit type conversion is the one that is done by the compiler, internally performed by the compiler. So the compiler decides. So for example, if the int type variable is assigned the value 10, and another variable y, which is of type float, is assigned the value of x. Since the value of x is an integer type, so when it is assigned on the variable y, it will be represented internally, it will be represented as a floating point number. So although it doesn't contain a decimal point value after any decimal point value, when it is stored inside the memory reserved by the variable y, it will be represented as floating point value. So it will be 10.0. So although it is not specified by the compiler, by the programmer, when that value is assigned on a floating point variable type, it will be converted into the floating point number. So such conversion is considered as an implicit type conversion.